Thanks everyone for joining. As Garrett mentioned, so name's Sean Van Staden. I run the partner solution architect team here at Starburst. I've been with the company about 3 years now. If you're not familiar with who we are or the open source tech that we built upon, I'll touch on that in a little bit, but I've been working with that tech now for about 8 years. It's very powerful piece of technology. It's got quite surprisingly widespread adoption across the industry, and we're going to talk all about that now and how it works with Looker to provide some very interesting analytics capability on the Lakehouse. So with that being said, let me kind of get right into it. So on the agenda, I'm going to first talk about some of those data challenges and pretty much the reason why Starburst exists. I'm going to follow that with some Starburst architecture. We will look at what the platform typically, how it's kind of deployed within an environment, and finally we're going to just talk about a bit about how Looker and Starburst interact, and then Huang's going to give us a demo, and then we'll have some time left over for Q&A. Awesome. All right. So without further ado, let's start with this first part here. So analytics anywhere on data everywhere. I actually quite like this one because it really does encapsulate I guess what the technology is capable of doing and the problems that we're trying to solve. And to really kind of open it up, I'm going to show this picture here. Might be a bit cheesy, but this is probably, a lot of organizations might look at this and say, yep, this is my data strategy, right? Because what an organization's main challenge is how to get insights across their different data systems. And if you think about that, what's actually happened over the course of the decades, when especially now the data is becoming, every year it just gets more and more prevalent. Data has been generated from a number of sort of newer types of places. We've now got generative AI coming in, onto the scene, so we're getting new data generated off of old data effectively. And what you're really looking at is a situation where you're creating, or as an organization, you are creating data silos, or you have created data silos, or your data is just naturally siloed. And it could be because you've got you're a multi-cloud organization, or you're an organization that's in the process of moving to or from the cloud from on-prem, because we see both now. And that type of situation leads to the fact that you're going to have data sitting everywhere. Best intentions, you might think about how data, consolidation of data into a single source of truth. A lot of organizations aspire to this. I would say from the birth of the database to the data warehouse, and then sort of technologies that came along that were supposed to be transformative, things like Hadoop, HDFS, distributed cheap storage, they didn't quite hit the mark, because the problem with bringing data into those types of sources is that these are typically monolithic architecture, and you end up just creating yet another data silo. And this is really ultimately the problem. So best intentions, what I'm trying to say here is it's very difficult for you to get to that single source of truth. And so from a Starburst perspective, we look at it very differently. For us, the single source of truth is not as important as a single point of access, right? So you may have a data lake, you may have multiple data lakes, you might have multiple data warehouses. That's all fine. You could have operational sources, you could have streaming sources, you could, your data could be coming in a number of different ways. You might have processes that consolidate that, as I mentioned, into a one or more single sources of truth. But for us, that part is less important as being able to get access to all of it simultaneously. And this is why we talk about a single point of access. And this is one thing that Starburst is very good at, is being able to look across all of that data, query it effectively. Now, you might ask, well, that's all great, but what does this have to do with the modern lakehouse? Well, for us, the lakehouse is actually one of the most important aspects of the single source, a single point of access. The lakehouse, we consider to be the data gravity of the situation, right? So I may have data in a warehouse, I might have data in, operational sources, but I still need some place where I can take advantage of, cheap commodity object storage in the cloud, open file formats that, the one that sort of really jumps out here for me is Parquet. It's pretty much used everywhere. And then sort of more on a more modern terms is having open table formats. So this really does sort of change things around, but this is fundamentally how we look at the world, where we say, you know what, the modern data lake, this is the core piece of it. And it's modern in the sense, and I'm going to talk about this open table format just a quick sec here, but that really changed what a data lake was capable of doing. Because in the past, you had, effectively commodity storage, you had open file formats, but data was relatively static. I'm talking about the early days of cloud object storage, the early days of things like Hive and Hadoop, and even Spark to some degree, before things like Delta Lake came along. But back in the day, this data was very hard to interact with. So it was a good place to store data, but it was very difficult to incrementally update or make changes to that data. Open table formats have very much changed that for the better, I would say, because when you sort of take that old style approach, separation of compute and storage, like I said, commodity storage, open file formats, and then you put something like an open table format on top of this, you now have what's effectively a modern data lake or lakehouse where you can incrementally interact with that data set. And so why this is important is now you've got something that has a like warehouse-like capabilities, but when you start bringing compute to bear on top of this with some of those other capabilities that I just spoke about, so being able to access data where it sits and being that single point of access, you now have what's effectively a modern data lakehouse architecture with data sitting inside and outside the lake, data sitting across multiple lakes, multiple clouds, multiple cloud regions, hybrid on-prem. Again, that part really doesn't matter. What's more important is having that single point of view. And so this, there's a lot of benefits to this. I touched on the warehouse-like capabilities. I mean, the other thing is it's vendor agnostic. I'm talking about Starburst, and you'll see this Trino over here. That's actually the open source product that we're built on top of. So the folks who built that at Facebook back when it was called Presto back in 2012, when they left Facebook, they helped co-found Starburst, and long story short, changed the name from Presto SQL to Trino, and then kind of like the rest is history. So, but the point there is that, you can plug Starburst on top of this with the Trino engine, but I can also equally plug a Spark engine on top of this. There's a number of different ways I can process this data in this type of format. That means it's more open to the customer. So the customer is not sort of locked into a single vendor. They have a little bit more freedom as to how they want to access that data. And then obviously, final point here is it's probably the most cost-effective and scalable way to store massive quantities of data. All good so far. Excellent. Right. So benefits. I mean, we obviously have a lot of customers who adopt this model. The types of benefits that you can realize from this approach could be varied, right? I mean, we're talking either faster time to insight for your business users. You could be lowering your TCO because you're just processing more efficiently. You could be improving your query performance. Kind of ties into the TCO point. And then finally, as an organization, and this one really sort of jumps out because if you've ever spoken to anyone from Starburst, chances are they've spoken to you about Comcast over here. They actually realized, $200 million worth of new revenue opportunity by taking the single point of access approach as opposed to trying to go through a long migration. And so all of this ties into faster time to insight, really, but these are sort of real benefits that customers have realized from adopting our platform. Excellent. I'm going to pause there for a second. Okay. All right. So before we get into the integration piece, one last slide on the high-level architecture. And this one I really like to show because it does encapsulate everything that Starburst really is, and where you should be, where Starburst fits into the ecosystem at a very abstract high level. And the key point to call out here is the fact that we're that engine that sits between the end users' data and the end users themselves. So a lot of the time, most of the folks who are using Starburst may or may not even realize they're using Starburst. And when we get to the Looker demo, you'll actually see what I mean by that. Because if I'm building out a report and a dashboard in Looker, that's what I'm using, right? I have a connection to Starburst. All that's really happening is Looker is effectively offloading that processing to Starburst. Starburst then becomes the engine that's able to read and join data real time between these different sources, effectively sort of leaving Looker to focus on the parts that it's good at. So building the Looker ML models and things of that nature. But the actual query processing is handled by Starburst. And that's true of any of our BI integrations, or even if you're using, you're not doing BI, you're doing some other type of activity, whether you're building, a Jupyter notebook, you're building a dbt data pipeline. That part doesn't really matter to us. That's the end user's primary interface with the platform. And then what we're doing is we're abstracting that, and we're effectively making all of those different data sources appear just like a single source to that end user. It goes back to that single point of access that I just mentioned repeatedly earlier. And so end user doesn't need to understand how to query data out of Delta Lake, or write an Oracle or a Postgres SQL query. That part's all handled by Starburst. This engine over here, very much look at it, what it is, which is a SQL engine. It takes SQL, it processes that data. It works and operates like any relational database. And what I really mean by that is it's got the intelligence to understand how to query those underlying systems. So it's not just about extracting, and I see a question there, can you do a cross-DB query? Yes, absolutely you can. Because it's not just about extracting chunks of data out the systems and then figuring out how to manage them together. When you run a query where you could be effectively joining a table from a Delta Lake table to a table in Postgres, the system has a cost-based optimizer that figures out the best way to extract that data. So the CBO goes through a few planning iterations to figure out the best execution plan. And then it might refactor the query. It might push down a predicate or a join condition to limit the amount of data that it actually needs to extract from the underlying system, thereby optimizing how much data is actually pulled from that system. And that's really fundamentally the heart of the query engine itself. It's about optimizing no matter where that data is, based on how the data is being joined by the end user. And that's pretty fundamental to the engine, because if I was working individually on those systems, I may not know the relationships between that data set. But Starburst is able to derive that automatically. So you can look at it as being able to have insights as to the data structure across all of the data sources that you're busy querying from. So it's very, very powerful in that regard. That's how I can do that join that I just described in a very interactive, performant way. The only real conditions that limit me is the bandwidth, right? So we don't break the laws of physics. If I'm trying to pull a billion rows out of a system across a very, very thin bandwidth, I mean, that's the part that's going to slow my query down effectively. But all things being equal, when it comes to the actual data processing itself, when it comes to the how to query that data, we can go as fast as those systems will allow us to go. Okay, so thank you for that question. Awesome. So there's a few more things here. I don't want to sort of belabor the point here, but because we are an enterprise application built on top of open source Trino, there are a lot of features that we add to the platform, and one of the key ones is governance and security. So we'll take a little bit of a brief look at that when we get to the demo part. I'll show a little bit of that at the end, but the neat part about that is that we are effectively an enterprise-wide, across an organization, enterprise-wide solution. We can have multiple different lines of business accessing our platform, because we're effectively connecting to all of the data, and then all you're doing from a governance and security perspective is you're applying rules as to which users are allowed to see what parts of the business. So you've got all of that flexibility built into the platform for you. You know, authenticated users coming into the system off of whatever your primary user identity platform or system is, and then we're just literally using all of that and then applying, giving the admin of the system the ability to apply the rules and permissions across what data sets are available to your various end users. All right. Okay. At this point, I want to hand it over to Huang and have him talk a little bit about the Google Starburst piece. But before I do, are there any questions up until this point? I did answer one.
Sean, I think I saw another one in the chat window.
Right. Okay. Oh, right. Cool. Right. The question is, how do you work between SQL and non-SQL DB? In fact, before we jump onto that, let's talk about that. So, great question. End user does not need to understand how to extract data from Mongo. To them, they're using tree NoSQL, right? So the connector that Starburst has, so we've got a dedicated Mongo connector, like we do with all of these sources. And if you want, you can always have a look at our documentation. I think we've got about 50 plus different connectors now. The connector understands how to access data there. So whether I'm querying a relational database, some files and object storage, a NoSQL source, or even like a Kafka stream, I can connect Starburst to that. I'm just writing, everything just comes back to me as a series of relational tables and views. So it's very simplistic in that regard, and the connector understands how to interpret what the user is writing as a query to what the native source requires when it comes to extracting data. So hopefully that answers the question then. Thank you. Perfect. Excellent. So, okay, Huang, over to you.
All right. Thanks, Sean, for the great introduction to Starburst and the Lakehouse architecture. So now we zeroing into the top of the data stack, which is the BI layer. So there's been lots of innovations around the BI space. We went from simple visualization in a spreadsheet to OLAP Cube and a full-fledged platform that can do pretty much anything that you want with your data, right? And so one of the best of its kind is Looker. It's a cloud-native data platform that has modernized the way analysts and engineers alike work with data and how businesses understand the data assets. So it's built on top of SQL, leveraging your favorite querying language, but supercharges it with LookML, a data modeling language that provides ways to define and curate all your data assets on Looker. So SQL is very easy to get started with, but it's a double-edged sword, and you can potentially get swarmed with fully written SQLs pretty quickly, especially if you're working in a large team at various proficiency level with SQL. So LookML is there to bring standardization and also offers oceans of functionalities like permission and access control, data governance, and semantic layer alike. So Looker also brings the best practices from the software engineering world into the data world, like version control, separations of production and development, CI/CD. You can implement basics of DevOps with Looker pretty easily. So now with Looker, your data team is now agile, and by enabling these practices via Looker, you can now be confident that whatever your data team delivers is trustworthy and reliable. Right? So trust in data means better decision making and overall better business outcome. And as for integration with data sources, so Looker works with any of the modern data stores, Snowflake, BigQuery, Redshift, etc., and the next generation like Starburst or Trino. The setup process is very straightforward, and there's comprehensive documents if you need help with any of the support databases. But again, Looker doesn't just start with Looker now and the new workflow. The possibilities here are endless. Right? You can embed Looker dashboards and reports in any of your applications and turn them into a data product. Or reuse the data models that you develop in Looker in other BI platforms like Looker Studio, Microsoft Fabric BI, and even Google Sheets. Can you point to the next slide, please, Sean? Thank you. So going back to our Lakehouse architecture here for a bit, this is how we envision what it looks like. At the bottom, we have all our data sources being managed with different resources on Google Cloud Platform. For example, BigQuery as your data warehouse, Cloud SQL for your applications, and on top of them is Starburst, which manages all of them seamlessly, right? So Starburst hides all of the complexities of stitching and moving data into one place. And so Looker sits on top of Starburst and its querying engine, and it doesn't have to worry about where the actual data lives. And Looker doesn't move any of your data into another black box like other BI tools. So in other words, your data stays within your database. Usually other BI tools often pull data into their own servers or cache, which means a lot of the benefits Starburst brings are negated. Looker connects and queries directly into your database. So in this case, Starburst. So you have all the data that you need at your fingertips. With Looker, you can connect to all your data sources, and then Starburst acts as a central hub for your data without you having to actually spend additional data engineering effort for extraction and load pipelines. And so, secondly, Looker standardizes how SQL is structured, right? Democratizing your data by opening up all silos with Starburst doesn't mean that you have actually self-serve analytics, right? So without proper data governance and the structure of the semantic layer that Looker helps implement, eventually what you'll be left with at the end is just data chaos. So inconsistent numbers, loss of trust from the stakeholders. So that's why there's LookML and the ecosystem around it to help you with your data modeling, to define and correct things like table relationships, dimensions, and measures and metrics. So once you have developed all the proper data models in the semantic layer, you can then start educate your users about self-serve analytics, and you can trust that the initiative will turn fruitful as Looker offer numerous features that help with implementing enterprise-grade data governance, right? Sean, can you move to the next one? So just a quick recap on what makes Looker so great as a platform for your data. So it is fast. It's any scale because it queries everything directly in your database and stores nothing in its server. So you can trust that your data is delivered at near real time, regardless of the data volume, and that all your data is secure because there's no intermediary, right? So couple this with Starburst as a modern querying engine, and you can potentially scale up to infinite. And with its mature LookML modern language and data governance capability, you can rest assured that the insights that you deliver to your stakeholders are accurate and reliable. And we are witnessing the rise of analytics engineering, and Looker is no stranger to that, right? So it has built-in features that brings the best from the software world to the data world, and it will take your developer experience to a whole new level, right? It's a tune built for the modern developer, for the modern data stack. But not just within Looker, the assets that you build in Looker can also be consumed via APIs, as well as direct connection to other platforms. You can embed it in your website or a data application. The user you don't have to go to Looker directly to appreciate the benefit that it brings to the whole organizations. So I think that should be it for the quick introduction to Looker, and I'm good with explaining all these things, and I think it's time that we pivot to an actionable demo to show you how it all works together. If you don't mind, I'm taking over, Sean, for this bit. I'm going to share my window. So we start off with the Starburst editor UI. Here we've seen all of the data source defined in one place. These are called catalogs in Starburst. Each catalog represents a connection to a single data source. So it can be a BigQuery, or it can be a cloud storage on Google, or it can be a database, a Postgres database, right? So once I expanded them, we then load it up with the schema within each database or catalogs. So I have a few simple queries here for demonstration. For the first one, we are joining a table, a customer table from the PostgreSQL database with an account table from BigQuery. So voila. So as you can see, the customer data lives in Postgres, while the accounts data live in BigQuery, and this is where Starburst comes into play, right? You can write queries and join these tables from different locations as if they live in the same locations. And Starburst is going to take care of the heavy work of bringing it all together and just returning the result for you. So here is another example of counting or calculating the loan amount for each customer. And so we're joining table from Postgres, BigQuery, and tables in the data lake defined in the cloud storage. And Starburst is going to take a few seconds to process, and that's the beauty of it. You don't have to worry about any of the backend data movement. If you can see the data in the data catalog, you can join them together. Right. So now we're moving to the Looker UI and see how Looker integrates with Starburst. Right. I have here on my screen the setting of a database connection to Trino. So essentially, this is just Starburst. The credential for this connection can be easily retrieved from Starburst UI itself. You can go to clusters, which in Starburst term is a compute. Then you will go to connection info for a cluster. So Looker is an officially supported client of Starburst, and you can see all these credentials information that you can copy and paste into the Looker connection setting up. And if we test these connections, right. So we might need to go back to connection for a bit. Starburst demo.
Yeah, I think in the Looker UI, when you're setting it up, that if you change anything, that it defaults it back to like 8080 or something like that, and we use the secure port 443. So yeah, but there you go.
Yeah, there you go. So it's as simple as that. Just copying some credentials info presented on the Starburst UI to the default fields in Looker, and you're good to go. So we're heading toward our another UI on Looker. So this is a UI for a dashboard. So this is the dashboard for our business health as Bus Bank. Right. This is one of the things I like about Looker UI. It's very clean and intuitive. There's isn't a lot of clutters. From here, you can sort of play with the visualization for a bit. You can hover some data points in this line chart. You can drill down into it to see the details. The data that actually makes up the data points. It's going to take a few seconds to load up. You can play around with the filters. Lots of options here. You can schedule for a delivery, like a daily delivery to your email inbox or to a Slack channel. You can actually embed the whole dashboard into another application just by getting the URL to the dashboard and embed it into the HTML code for your website. So besides drilling down into the chart, you can actually see the data that makes up the visualization or do additional ad hoc analysis using the visualization as a starting point, right? So Looker took us to another UI called the Explore UI. So an Explore is in building blocks for reports or dashboards on Looker. It can also be a starting point for any of your self-serve analysis. So on the left, you'll see in a panel with some lots of dimensions and measures. By selecting this field, you tell Looker what to query, what query it needs to write. So here we have a few dozen dimensions and measures already. If we go to this SQL tab right here, we can see the query that Looker wrote for us. Then it should be the exact query that Starburst should run. So I'm gonna break the cache for this query and do a full refresh on this one. So if you're going back to the Starburst UI and to the query history tab right here, you're gonna see. Oh, gonna take a few minutes more. I'm gonna do another refresh on this one. Refresh the results for the cached. All right. Yeah, we have to actually have to do a full refresh of the page. And if you go to this query ID right here, you're gonna see the same query that we have on the Looker Explore UI, and you can actually see where this query is sent from. Right, it's from the Looker client we set up earlier using the cluster cloud demo. So that's the beauty of Starburst and Looker, right? Looker doesn't pull data into its server and process there. It sends the queries directly to Starburst for processing. This is what we call in-database executions. So I'm going to go back to the Explore UI and start adding a few more dimensions here. We're going to pick the status for the mortgage status, and the SQL should now be updated with additional fields called mortgage status here. We're going to run the query again. So now the return result should have additional column for mortgage status, both for the visualization and the table result itself. So this analysis could have been written by you or somebody else, right? Which might not be the best use of your time. Writing SQL means you're gonna have mistakes, so you eventually find out that your query might be different from somebody else's. This is where LookML shines, right? It standardizes the SQL that you need to run in order to get the result, and the SQL and the results are going to be the same for everyone who selects the same fields presented here. So let's take a look at the LookML code behind the Explore right here. So here is another UI on Looker called the LookML IDE. On the left, you will see a project structure, with view files from different data locations and model file and dashboard file. Right? So these are the files that you will be working with most of the time if you work with LookML. View files are essentially files that describe this table in the underlying databases. Within the view file, you will find the reference to the actual table in the Starburst catalog, right? So for example, this account field, we're referencing the account table in the BigQuery catalog. There's also dimensions. Dimensions can be direct reference to the underlying columns in the table or derived dimensions. For example, for the auto loan balance dimension, we are referencing the direct actual column from the account table. But if we're going to another dimension in the customer view, called Fico range. So this dimension is built off on the Fico dimensions. So we call these derived dimensions. Right? Besides dimension, we also have measures. Measures are essentially aggregations. So for aggregation, we can define the type of aggregations. We have count aggregations, average. There's also sum and number. So numbers aggregation are essentially derived measures. So this is how we define metrics, and by extension, the semantic layer in Looker by using measures. So after all defining our dimension and the measures, we're gonna go to the modify and bring all the views together into one explore, right? And explore essentially defines what we see on the explore UI right here, right? So for the explore UI, we're seeing the account view, customer profile, and product profile, which is essentially just all the views that we're defined here within the explore, right? So let's go back to our metric layer for a bit. So you can define metrics as a standalone measures like these, or you can combine them together to create a new metrics, right? Before doing so, we need to go to development mode, as we are now in a read-only mode. So inside, you will see that there's an indication at the very top of the page that you are now in development mode. And there's a newly added measure called average loan per account. So what we do with this is we're going to go back to the Explore UI. You will notice that this Explore is not refreshed yet. So we're going to hit refresh. And expand the account view within the Explorer, and we're going to see the average loan per account measure. If we exit the development mode, we're not going to see the measure again. So Looker has created a very seamless experience for developer to develop on the platform itself. Now, if we go back to, if we turn on the development mode again, and hold in the newly created measure, I'm going to take out the average outstanding balance. So if you go to the part SQL panel, we're going to see the definition for, or the actual calculation for this fee, for this metric. It's basically a count of all the loans divided by the count of the whole table, right? Which is what we have defined here in the definition for the measure, right? So we're not using, we're not calculating the measure from scratch. We're actually reusing the measures that we defined previously for the count and the total loans measures. So that's the beauty of looking at. It's very extensible. You can already tell that for the account view, we have already defined within the Google BigQuery, Google Cloud Storage BigQuery catalog view right here, but we have extended it to include new measures or metrics within the metric layer here. Right? So that's the beauty of LookML and how it implements strong data governance. It ensures everyone have access to the same thing, and there's consistency in what people see, right? And as we've seen from previous demos, Starburst has done the heavy lifting of consolidate all data into one place, and LookML helps consolidate or enforce data governance by making sure that everyone sees the same thing. And for a Looker developer, you don't really need to care about that, the data engineering work behind the scene. You just need to know where to get your data, and you can get right into great data modeling and deliver the insights to your stakeholders. So that concludes my live demo, and now I'll pass it back to Sean to wrap up our presentation with maybe a short demo on
Perfect. Thanks, Wang. Yeah, I mean, so that was a great demo. I mean, you could see, like, just from a pure Looker perspective. So, you know, it's a perfect example how Wang was showing how, you know, as a Looker developer, he's pretty much working in that space. And you saw every time he went. In fact, I'm going to start sharing my screen again here because I do want to kind of show this part here. But as he was flipping back to Starburst, and by the way, let me just wait for it to come up. This is our, let me make this a bit bigger. This is our Galaxy, this is our managed SaaS platform, Galaxy. So, you know, all of those compute resources we're managing ourselves. We do also have what we call a self-install version of the platform called Starburst Enterprise, where you can actually run that yourself. But the SaaS one is a bit easier and a bit more convenient because, you know, Starburst takes care of running those clusters for you. They just logically run in the background. You just connect in your data. But what I really wanted to show was, you know, that experience, because from Huang's perspective, because when he was coming in here, he was basically seeing only what he was able to see. And that was because everything that he was looking at was tied to this Google Cloud demo role that you can see at the top here underneath my username. And if you kind of take a step back and think what an organization might have when they've got Starburst connected to the environment, you know, they might have access to, you know, there might be your environment, well, your Starburst environment might be connecting to data sets across your organization. And so, as an example, if I switched over to the account admin role, you're going to start seeing, oh, okay, there's a lot more clusters now in the system here. If I have a look at all of the different catalogs I've got connected, I'm now looking at catalogs that are potentially across my organization. So not just what I've got in Google Cloud, but, you know, I'm looking at stuff that I've got in AWS. I'm looking at stuff that I've got in Azure. And so from this goes back to the governance perspective, right? So as my groups of users come into the platform, I can restrict what they've got access to, and that's built natively into the platform. We can integrate with external providers as well, but for convenience, you know, I can define all of that here, that access control here. So I've got a number of tools that allow me to set that up globally. So I might be using Dataplex in Google. I might be using Lake Formation in AWS. You know, I might be using some other means of managing my data sets. But from a Starburst perspective, we can consolidate all of that under a single umbrella. And so now, across the org, doesn't matter what data sets I'm touching, I can now provide access permissions to clusters, to data sources, even down to the rows and the columns of data on the tables. So, you know, I can even filter data out. So if I don't want certain users to retrieve certain data sets, you know, certain rows, because maybe there's some, you know, residency restrictions or whatever, you know, maybe there's column masks I want to apply because I don't want people to look at, you know, SSNs. I can do all of that here. Then no matter what query is being executed, I mean, I could give the same query to, you know, 10 different users on my platform. The single result that they return, if they run that same query, could be different based on the rules that I've set up over here. So it's going to change based on that. So that becomes very powerful. As you can see, you know, like me as the admin, I've got access to everything. So I can start querying data across the organization. But that's just to, you know, kind of give you a sense as to from a management perspective how this sort of ties more into that self-service platform that was mentioned earlier, right? This is very much a case of a place where you set up your access to your sources, and then, sorry, you set up your connections to your sources, and then you set up the access based on who your users are and what their roles are within the organization. Okay, so I'm gonna stop it there because we've got just over 10 minutes left, but I do want to open it up for some more questions if anybody's got. Access control sync with Snowflake or Big BQ. So Not really, and I'll tell you why. Because like with both Snowflake, well, let's look at Snowflake for a second. So with Snowflake, we can use the identity of the person. So like typically your Snowflake's going to use like Okta or some other mechanism to, some other single sign-on mechanism into Snowflake. We can actually use that same connection so that I don't have to have a static, service account level connection to my Snowflake environment. I can literally just use my same identity. And so Starburst will actually pass that identity through to Snowflake when it's trying to access data. So in a situation like that, we don't really need to apply access control, because again, if I'm giving the same query to a bunch of different users, whenever a user runs that, whenever they're hitting Snowflake, they're effectively hitting Snowflake with their identity. So it doesn't make a lot of sense for us to necessarily have that over here. What I can actually do though is add additional layer of control to Snowflake, because the data owner might say, you know what, you got to come in to the application and you've got to abide by the single sign-on identity provider. So we check that box over there. But as the Starburst owner, I can now add additional restrictions, because maybe I don't want them querying certain tables or something like that. So I can apply those access limitations directly within Starburst. BQ works similarly. We don't quite have OAuth through to BQ, so we are somewhat reliant on service account level. But in a situation like that, I would, and so this is where, we're not quite sort of synchronizing the access control there. You would still have to apply access control within Starburst, specifically around BQ. But hopefully that kind of clears it up, because for most of our other connections, we are definitely leveraging the underlying systems identity. Okay. So second question here. I want to know how much time I save when using Starburst. For example, the same query, what's the time difference between sending query directly from Looker to DB versus through Starburst? Yeah, well, that's a good question. I'm going to say it probably depends on your data. So if you are in a situation where you potentially are trying to run analytics on a lake, where you could have, multiple terabytes, maybe even up to the petabyte scale. I mean, we've got some customers who, operating at that sort of level. We're definitely going to be faster, because the engine was built for that kind of processing. Also, again, it depends on the query. When you start to talk about some of the joins that I was mentioning earlier, Starburst has the intelligence built in to understand how to trim down how much data it needs to extract. So everything that I mentioned earlier about the CBO examining, table statistics. So in situations like that, where you have potentially joining large tables together, but you are, only returning small result sets out there, Starburst definitely going to be quicker, because Looker just does not have the ability to understand the relationship between those tables across those different systems. So Looker is going to try extract, all of the data sets, then do the joins, and then give you the answer, whereas Starburst is going to pre-filter those that data. So it's going to be quicker in that scenario. I mean, there are other situations where Looker will be just as fast as Starburst, especially when you start talking about much smaller discrete sets of data, possibly even data that Looker can just sort of cache. In situations like that, it's kind of like a much of a muchness. The one thing I'll say is that, obviously from a Starburst perspective, we're not caching. Every time you're hitting refresh, like you saw over there in Looker, you're getting the real results live from the underlying system, because the query is being re-executed by Starburst every single time. So there's no caching involved or anything like that. Okay. Perfect. Nam, yeah, you're the man with the questions. So, Jonathan, what you were showing before that was being served up to Looker, was that a data product? So no, those were queries run directly. We do have data products. So I mean, if you're familiar with Starburst, if you maybe had a look over here, I'll have a quick segue into that one there, because this is pretty interesting. But those were just direct queries that were being run. And I mean, even when you've got a data product, at the end of the day, you still have to run a query, right? It's going to turn into some type of SQL. What data products within Starburst give you is additional business context around the data set. because if you kind of think about it from the end user's perspective, you know, and I'll go back to the catalogs. If I look at this, I mean, as a business user, I may or may not have any understanding where my data is, or I look at the stuff and I say, okay, this is great. BigQuery and Postgres, my S3 Lakehouse. Okay, cool. You know, I don't know what data is stored there. So this is why we have data products, right? Because somebody who does have that information, who understands the relationship where the data is, can then sort of translate that into a business context. And that's really where the data product comes into play. So now you're looking at something like New York rideshare data, where I've got information, metadata around that object. Underneath this is going to be, you can see I've got NYC rides, S3 ride data. That is if I looked in my catalogs, I will find that schema. And I can even see who owns it. And I could query that. This is probably going to be a series of, in fact, let me look at the schema here. It's going to be a series of views and possibly materialized views. But there you go. So if I look there, so that schema roughly translates to that data product. And within here, I'll see how many objects have been created. So I can go through that process of setting up a data product. In this case, there's quite a few objects here. There's a couple of views, there's a couple of materialized, well, quite a few materialized views, but that encapsulates my data product. So for the end user, you know, who wants to build a report or dashboard on that New York, what do you call, cab data? Let me go back to it. Rideshare data. You know, I understand that. I don't necessarily understand how the data was sort of pulled together, and that's really the purpose of it. But so hopefully that kind of clears that up. Excellent. Perfect. Thank you. No, thank you for the question. That's great. I was remiss to not talk about our data products because it is one of the most popular parts of the platform. Because it really does help the platform become more self-service. Excellent. Any other questions? Okay. Excellent. Well, 4 minutes to spare. But I think that's
I think I can fill those 4 minutes if you guys don't mind.
I don't mind.
All right, great. So thank you everyone for joining. John Barrett, CEO, founder of June Solutions. Sean, excellent presentation. Really loved everything that you've shown us here with Starburst. It's a great little taste of, you know, what you can do. And Huang, obviously great work with Looker. I love seeing, you know, it tied together. We're offering for everyone who attended and in the recording. So for future viewers, we want to make sure that we have a good pathway for people who are interested in either getting involved with Starburst or Starburst and Looker. I think the current offer is 4 weeks of trial Looker and 4 weeks of trial with Starburst, with I think 12 days support from June. If that's something you're interested in launching a platform like this. So we'll send out the recording. This will also be on YouTube, and we'll send out more information about how we're gonna help everyone kind of roll out this this platform in their data architecture, right? So thank you all so much for joining us. If there's no more questions, Sean, Huang, thank you so much for your time. Really appreciate it.